do you do 3? Take a look. Oh. Cool. Yeah, let's take a look at number 3. All right. Yeah. Let's see if we can figure this out. All right, so number 3, I wouldn't give you one like this, but let's do it. 2 rectangular lots. So those are both the same size. Are enclosed by fencing perimeter of a rectangular lot. Putting a fence across the middle. Okay, each lot contains 1,200 square feet. Okay, what is the minimum amount of fence needed for this? So all of these would be a distance of x. Okay, so this is x, this is x, and this is x. All right, so let's think about this. I have a total area of 2,400 square feet. Agree? So if we just take the area of a rectangle from elementary school and do this, I know that I have a length that I don't know, but I have a width that we're going to call x. So that means that my length is going to be 2,400 divided by x. Okay, so then I'm going to go 2,400 over x. That's this whole length here. So how do I want to do this? So it was total amount of fencing. So I know that my perimeter of this would be 2 times 2,400 over x plus I have the 3 x's in between. Okay, so that's going to give me p equals 480 over x plus 3x. And I think with that we can then solve for x. Because I don't know what the perimeter exactly is, but I think if I plug that into Desmos, that should give us some characteristics for our dimensions, our minimum dimensions. So let's go. You guys got all quiet on me. Did I do something wrong? So I'm going to go y equals 4,800 over x over x plus 3x. All right, let's see what this gives us. Zoom out until we see something. There we go. So obviously, because this is both negative numbers, this is not going to work for us. So I'm going to find that point right there. And that should give us the, let's see, come on, no, go there, go here, go here. So it looks like if x was 40, if x is 40, then our perimeter is 240 because we were doing that way. So 40 comma 240. So we found that the point 40 comma 240 works. Okay, but the 240 deals with the perimeter. If I plugged 40 in here, I know that's 40, and that's 40, and that's 40. And then if I plug 40 in here, 2,400 over 40 is going to be 240 over that, so that's 60. So if I had lengths of 60 and then my middle forest was 40 and 40 and 40, that's going to encompass our 1,200 square feet. And that's it. Kind of a goofier problem to think about, but you kind of have to manipulate a little bit. But what else did you see that I can help you with? else did you see that I can be helpful to help you along, guide you along, inspire you? We're good? Video games, let me see. Yeah.
Can you do 5?
5? Rectangular box one?
Yes.
You got it. All right. So number 5, we have a rectangular box with square base formed with a piece of metal with 20 by 30 inch sides. If the square, okay, so let's change number 5. So we have a square and then we basically have this. Bless you. Do the best you can. Draw yourselves a 3D box. This is kind of flipping back and forth at me now. All right, so we know that if a square with side length x is cut from each of the 4 corners and folded up. Oh, wait. No, I misread the problem. This is going to be one of the problems that we had this. So this is x by x, 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 x. And if the entire length here was 30, that means this is going to be 30 minus 2x. And if the other side is 20, then this would be 20 minus 2x. And maximize the volume. So my volume, I have one of the sides which is x, one of the sides that's 20 minus 2x, and one of the sides that is 30 minus 2x. And if I graph that on Desmos, y equals x times 30 minus 2x and 20 minus 2x. And zoom in a little bit. All right, so I'm looking for the top of something. So I'm looking for the top of those middle 2 lines. There we go. So find that tip right there. So it looks like we have a 3.9 inch cut. That would give us a volume of our box of roughly 1056.3. That's how you do that problem. Anything else I can help you with? Yeah.
Wait, can you go back like
The
picture of the box that you
yeah.
Why is it minus 2x?
Okay, because you have 20 here, 30 here. I'm cutting a square out of each of the corners. That's x by x. So if you think about it, if this whole length here was 30, but I'm going to subtract both those x's, and this whole side was 20, and I subtract both of those, that's why this piece right here is 20 minus 2x, and this piece right here is 30 minus 2x. And then the third dimension is just x tall.
Oh, so you're just solving to building stuff. Okay.
Anything else I can help you with? We're good? Everyone's happy, content? Okay with the hotel room, the landscaper? Rectangular area enclosed, divided into thirds? Let's hit number 8. Number 8 can be kind of a goofy one. So as a rectangular area is to be enclosed and divided into thirds. So you have that. The family has only $800 to spend on fencing. That's our total. And then the outside fence costs $10 per foot, and the dividers cost $20 per foot. So this side is $10 per foot, and then these would be 20 per foot. So I got 20x here a couple times, and then on the bottom I also have 10x. Okay, so what dimensions that will maximize the area enclosed in the family's budget? So right now I know that my perimeter would be 4 times 20x, and my outside dimensions be 2 times 10x because I have top and bottom. So that's going to give me 80x plus 20x. And I have a maximum of, so that's going to give me 100x equals the 800. So x is equal to 8. Yeah.
Why'd you make the two of the sides 20x? 'Cause aren't those like the outside also? So those would be 10x?
Oh,
The way I did it, I said
let's see.
4 by 10x.
The outside fence is $10.
So like, shouldn't
Oh. So you're saying that this should be, maybe I misread that. You think that's 10 and that's 10?
yeah, and then just the like divide.
Okay. Yeah, let's try that. So 1, 2, 3, 4, that's 40x. That's 80x equals 800. I do that math right? 10 plus 10 plus 10 plus 10. 80. X equals 100. That might be worth. That might work. I'll do that.
Yeah.
I could see that argument.
And then x is 10.
10. Jeez. If Stirrup could do math, you guys would learn so much more. Anything else I can help you with on there? Are we feeling fine about these little word problems? Are you getting your items done? Okay, so I'm looking at worksheet 5.6, candy box. We got that. Study shows that. Owner of retail lumber wants to construct. I think you can do that. Yeah, so why don't I give you the rest of the period to work on worksheet 5.6, 1 through 5, and then we'll tomorrow, and today's Tuesday, right? Tomorrow and Thursday, we will do the chapter 5 review, and then Friday, we will learn about physics and oranges. That's what I got. Sound good?